Alrighty, so we're finished with the second exam. I'm going to go over the solutions for it, just so you all have them. This one, the average was actually around the same average as the first exam, but there were a couple problems that got a lot of people that I wasn't really expecting, to get a lot of people. So I'll go over them, just make sure that you understand where you went wrong. I believe the fourth exam will have questions from the first half of the semester, but you'll need to double check with your lecturers. So I'm going to go over, so there are a couple different versions of the exams, different number orders, different numbers. I'm going to pick one of them and just go through it. So the first one I'm going to go over is you had this integral, or an integral of this sort. It was, 1 over something to power. So this one is the integral from -3 to 2, 1 over x plus 1 to the 4/3 dx. So the first thing you should note with this one is discontinuous at x equals -1. That comes from looking at the numerator, the denominator there. So this is an improper integral, so we need to treat it as an improper integral. So this is going to be the integral from -3 to -1, 1 over x plus 1 to the 4/3 dx plus the integral from -1 to 2, 1 over x plus 1 to the 4/3. And now we just have to show one diverges. So either you show one diverges or you compute both of them. If they both converge, then your answer is the sum of those two integrals. But I'm kind of giving it away. This is going to diverge. I set this up so it would diverge. So let's look at how to do one. I'll pick just one of them. Let's do the integral from -3 to -1 of 1 over x plus 1 to the 4/3 dx. So here I need to change this into a limit. This will be limit as t approaches -1 from the left of the integral from -3 to t, 1 over x plus 1 to the 4/3 dx. And now you can do the integral. So this one I picked one that would be very easy to integrate. You can do a u substitution if you need it, but this is going to be x plus 1 to the -1/3 over -1/3. And all the versions of the test had something that was this quick to integrate. And then we have I've integrated, so I'm going to drop the integral sign, and now I'm going to evaluate this from -3 to t, and what I was meant to write there was the limit here. Limit as t approaches -1 from the left of that. So I'm going to pull the -1/3 out. That's going to become a -3 out front because it's divided by -1/3. And then I have the limit t approaching -1 from the left. I'm going to evaluate this thing. So this x plus 1 to the -1/3, this is 1 over. I'm going to plug a t in, t plus 1 to the 1/3 down here, minus what I get when I plug in x equals -3. So this is going to be 1 over -2 to the 1/3 down here. Okay, and now if I look at this, I can see that this term here diverges. It's going off to infinity, or minus infinity, doesn't really matter, it just needs to be one of them. So this whole thing diverges. So, the moral of this story is anytime you're handed an integral, you need to make sure that it's continuous on the range that you're integrating on. So, if it's not, you have to treat it as an improper integral, break it up, treat it with limits, because that's how we define these things. The other thing I want to mention is, so having, the cube root of a negative number down here confused a lot of people. So any number besides 0 has exactly 3 cube roots. And we're always going to take the real one. So if you go on to take, a course in complex numbers, you'll talk about how to find the complex ones. But because, we're talking about real numbers, cube roots of negative numbers are just negative numbers. Just like cubes of negative numbers are negative numbers. So, we're going to assume that the cube root of -1 is -1 for us. And again, if you go on to complex numbers, you'll talk about, what else can happen with that. And if you're uncomfortable, just leave it as, the cube root of -1 if you don't want to think about anything else like that. But just the idea is, you can evaluate cube roots of negative numbers and it'd still be real. A lot of people wrote that it was divergent because you had the cube root of a negative number, but that doesn't make that divergent. Okay, so number 2. So this one was to determine if the integral is proper or improper, and explain. So this was supposed to be, a quick one to do. I just wanted to know, if these things were proper integrals or not, and I think the issue is a lot of people didn't understand what I was asking, and I think that goes back to, knowing these definitions. So, again, all of these are different for different people. Let me do this one. Yeah. So A for this one was the integral from 0 to 3 of 1 over x plus 3 dx. So the first thing you want to check again, so what you're really looking for is, are any of these infinite? No, it's not type 1, improper. So we look for discontinuities. This thing is discontinuous at x equals -3, but you'll notice x equals -3 is not in the integration range, 0 to 3. So this is proper. It would be improper if, I was integrating and -3 fell into the integration range. And so a lot of people, I think, lost time on this one by trying to evaluate all these integrals. I didn't ask for evaluation, so just please read these directions carefully. I wasn't expecting anybody to evaluate it, otherwise I would have, caps, don't evaluate these, if I thought that, that was going to be a problem. Part B, the integral from 0 to 2 pi, secant squared x dx. So again, we don't have any infinite intervals, so it's not improper because of that. But remember here that secant squared is 1 over cosine squared. So this is going to be discontinuous when cosine is equal to 0. And this happens, at pi over 2 and 3 pi over 2. And those fall in, 0 to 2 pi. So this is improper because it's discontinuous on our integration range. Part C, integral from 0 to 1, 1 over the square root of x dx. Again, no infinities there. There was one of the questions that I pulled from had, an infinity in the integration. There's also a discontinuity in there. I threw that in there. If you caught either one, I gave you the full credit for it. And we didn't talk about how to evaluate those. So, if you didn't catch both of them, it's fine. We hadn't seen, one where both happened. But again, if you caught either the infinity or the discontinuity, I gave you all the points for that one. Anyway, so this one, again, square root of x, discontinuous at x equals 0, and x equals 0 is in 0 to 1. Well, we'll say 0 is in the range 0 to 1 there. So this one is improper. Again, this one was just supposed to test, do you know what an improper integral is? Can you determine it? If you can do that, I trust that you guys, especially after doing the first question, can set up these integrals. So that takes care of number 2. Number 3, this was the one that I wasn't expecting to throw so many people for a loop, but it did. So let's do this one. So we want to set up the integral that gives the arc length function for the hyperbola. This is, extraneous information. You don't need to know that's a hyperbola. I just give you the equation for the, what did I do? The right half. X greater than or equal to 0 of the hyperbola x squared over 9 plus y squared over 4 is equal to 1, starting at 3, 0. So I asked you to just set up the integral, don't evaluate it. I don't think you would have been able to evaluate it. I didn't try doing that. And this is just, testing if you can set up these integrals. Most of the time you'll just hand them to a computer afterwards. Okay, so the first hint I gave you here is I told you x is greater than or equal to 0. So what I was trying to lead you to there is, if you look at this equation and you think about the equation for arc length. So the arc length function is either, s of x is going to be the integral from x0 to x square root of 1 plus dy dx squared dx, or s of y if you want to do it in terms of y. If your variable is y, you start at the point y0, go to your variable y, square root of 1 plus dx dy squared dy here. So, again, depending on the problem, sometimes I ask for the right half, sometimes I ask for the upper half. It just depends on which one you got, and sometimes it was a hyperbola, sometimes it was an ellipse. No, sorry, this is the ellipse here. This is the equation of an ellipse. Sorry, I saw the plus sign and was confused by that for a second because I said hyperbola. So this is an ellipse, 2 L's. So before I go on, these are the formulas we're gonna set up, but there were a couple people who parameterized. So I wasn't expecting this, but we did talk about how to find arc length via parameterization. So if you know how to parameterize an ellipse, it's very similar to a circle. Instead of having one value of the radius, you have 2. It's your major and minor axes. So this one would be x equals 3 cosine theta, y is equal to 2 sine theta. That works. You have to be careful because this is going to be a variable up here, and you have to determine what that is in terms of your theta. But I think for that one, I think the value you would go up to is just your parameterization value. So for instance, if x was equal to 2 or 3 cosine theta, this integral would go from 0 to 3 cosine theta there. I believe so, at least. It's not a problem I've thought about. Most people, I think there was one person who actually left this variable when they did the parameterization of the ellipse. The other thing I want to warn about is, that I didn't just have an ellipse, I had also the hyperbola. Again, I wasn't expecting parameterizations. So the parameterization of the hyperbola is different from the ellipse. A lot of people tried using the parameterization for the ellipse. That doesn't work for, the formula of the hyperbola. So just if you're interested, the ellipse uses sines and cosines. The hyperbola uses hyperbolics, hence the name hyperbola. So you would have sinh and cosh. And again, I know there was a homework problem where you had to use sinh and cosh. It wasn't what I was expecting for this problem. What I'm about to show you is what I was expecting for this problem. So I'll stop talking and do this. So again, my hint for you was that x is greater than or equal to 0. I can see that, this equation, x squared over 9 plus y squared over 4 is equal to 1. That's very easily solvable for x here. So if I go ahead and do that, I'm going to get x squared over 9 is equal to 1 minus y squared over 4. So x squared is equal to 9 minus 9y squared over 4. So x is equal to plus or minus the square root of 9 minus 9y squared over 4. And I'm only going to take the positive root here because x is greater than or equal to 0. I don't think I did the left half or the lower half for any of them. I wasn't trying to be that tricky. The other thing I would have done is y is greater than or equal to 0. In that case, you would have just solved the equation for y. Okay, so now I just need this derivative. So I'm going to do dx dy. So this is going to be, I'll do it step by step. When I was taking this exam to see how time was, I did this all in one step. So this is going to be 1/2 times 9 minus 9y squared over 4 to the minus 1/2 because of power rule. And then I use chain rule and I multiply by the derivative of the inside. Derivative of the inside here is 9y over 4 with a minus sign. Sorry, 9y over 2. Yeah, sorry. The 2 comes from the power of 2 I brought down from the y. You could also, cancel the power of 2 out front. I think that's what I did originally. This is fine though. So this is going to be negative 9y over 4 divided by the square root of 9 minus 9y squared over 4 because of that negative 1/2 power. So now plugging in, I'm going to get s of y. Y is my variable here. Hang on. Let me change these formulas. Sorry. Don't want to make that mistake. So yeah, so you don't want your, sorry, I would have caught this. You don't want your integration variable to, appear in your bounds. That is confusing. I'll explain why in a second. It'll be dx dt. So the idea is that this is a function. If I plug a number into here, if I plugged in 3 for x, I would put 3 up there. But if there are x's inside here, plugging 3 in for x, kind of insinuates or it implies that I should also plug 3 in for the x's inside the square root, which is why we use a different variable to avoid confusion like that. Okay, so s of y then is going to be equal to the integral from the starting point. So let's look at our starting point. Starting at 3, 0. My y value then starts at 0 here. So it's going to be the integral from 0 to y, square root of 1 plus the derivative, with all my y's replaced with t's. I'm going to square this thing, right? So I'm just going to go ahead and drop the negative, and this is going to be 9y over 4 divided by the square root of 9 minus 9y squared over 4. Sorry, these should be t's. So 9t over 4 divided by that t squared dt. And I didn't really need it simplified any more than this. I'm not having you evaluate it. I'm okay with this. You should check, get an idea of what the lecturer now, and it depends on which section you're in, but what the lecturer now expects in terms of simplification. This for me is the final answer. So I'm going to stop at this. So I'm going to split this up into 2 videos just so I'm not talking for so long. I don't want to make a huge mistake later on and have to start over. So I'm going to stop here and we'll continue on in a couple seconds.